Okay, I'm going to start on version 2 of the test, problem 2a. Okay, sine inverse sine 7 pi over 9. Now, if this angle rested in the permitted area, such as, what is the permitted for this negative pi over 2? Pi over 2. If this angle was in this permissible interval, then this would be a read-through problem. We would get back the very same thing we start with. However, 7 pi lies outside of this area, therefore we would need to place the angle and actually do all the intricate steps involved. Okay, so 7 pi over 9 would be something like this. 7 pi over 9. Now, what is the reference angle formed by this angle? That is 2 pi over 9. Okay, now, once we realize where this angle falls, we can determine what is the signage in front of it. In other words, plus or minus. In the second quadrant, sine is positive. Therefore, when we're looking to place the angle in the inverse restrictions, which are right there. Okay, so inverse is restricted to the first and fourth quadrant. The first quadrant is going to produce positive results. The fourth quadrant is going to produce negative results, and we are looking for a positive result. Therefore, we know we're going to be in here, and it's just a matter of placing this reference angle in the first quadrant. So 2 pi over 9, place it in here. Well, it's just a matter of just right there, 2 pi over 9 in the first quadrant. So the answer to this is 2 pi over 9. Now, next, moving on. Cotangent of cotangent, which problem? Where's the inverse here? Sorry, I forgot that. Cotangent inverse. Okay. So let's place this angle first. Again, we have to realize that lies outside permissible area. Therefore, we know we have to go to place the angle. Negative pi over 4 is negative pi over 4 right there. Now, what is cotangent in this quadrant? It is negative. Therefore, we're looking at the inverse restrictions, which are right there. Cotangent, in this quadrant, the values will be positive. Here it will be negative. Therefore, we know what we're looking for is the reference angle of pi over 4. Now, remember, the reference angle pi over 4, but place it in the second quadrant. So, if this is pi over 4, being this is a reference angle, what is the angle itself? And the angle is 3 pi over 4. Okay, so that's 3 pi over 4 is the answer here. Okay, I'll have to move relatively quickly in order to make this video within 10 minutes of YouTube limitation. Alright, so cotangent inverse, cotangent 8 pi over 7. Come on. This is a lot more difficult than it looks. Anyway, so cotangent inverse here is, let's place the angle right away. So the angle would go something like this. Now, it's not necessarily to scale. This may not be 8 pi over 7, but that's good enough as long as we land in the right quadrant. Now, what is our reference angle? Pi over 7. That's our reference angle. What is cotangent in this quadrant? All students take calculus, and here it says tangent and cotangent positive, therefore this is positive. So on the cotangent inverse restriction, this is going to be positive quadrant, this is going to be negative, therefore we know we're dealing with quadrant 1. That will produce, and what angle in quadrant 1 will produce, well, let me rephrase that. We're looking for what angle in the first quadrant that will produce positive results. Well, we're looking at pi over 7. That's the angle. We're placing this reference angle in the first quadrant. So that's pi over 7 is the answer to this question. Now sine inverse of negative 7 over 6. Now two quick ways of doing this. One way to realize that this value lies outside. Okay, one thing to notice. Now the problem is going the other way. We have the inverse inside the parentheses. Therefore, we're looking one of two ways, either at the restriction or at the triangles. While looking at the restriction side, sine typically of any theta or x lies between 1 and negative 1. Now, in this particular case, we have negative 7 over 6. We have to realize it's outside this area. It's out here. It's less than negative 1. Therefore, just by looking at it, we should be able to determine that this the sine of such angle basically does not exist that produces this. If you did not realize that and actually try to do a triangle, okay, triangle with sine is opposite over adjacent, so let's try to play, opposite over, so my opposite, I said opposite, opposite over hypotenuse of 6, well, no such triangle is possible where hypotenuse is smaller than the value of one of the other sides. Okay, so we should realize that this does not exist, so it is DNE. Okay, I'm making okay time. Okay, 2e. Cosine inverse of cosine 10 pi over 7. Right, it's not a read-through problem, we realize right away, so let's place the angle itself. Well, 10 pi over 7, if this is 7 pi, so something like this. Again, this is not necessarily to scale, but as long as I'm in the right quadrant and I'm labeling my reference angle properly, I'm okay. What is my reference angle here? Reference angle is 3 pi over 7. That's this angle right here from the nearest x-axis. Therefore, what's my cosine in this quadrant? Cosine is negative. Now on the inverse side, cosines are here. This is going to produce, the first quadrant is going to produce positive results. This is going to produce negative results. So we are looking for a negative. And so we have to place this reference angle in this quadrant. So roughly 3 pi over 7. Well, once we place the reference angle, what we're looking for is the angle that produced that reference angle. And that we read off of the initial side, which lies on the positive x-axis. So how would you label this side, this angle? This would be 7 pi minus 3 pi. So this is 4 pi over 7. That's this angle right here. And that is what we're looking for. 4 pi over 7 is our answer. All right, 2F. Okay, sine inverse negative square root of 2 over 3. Again, the inverse is inside, so we have to think about what we have here. Is this possible? Well, yeah. Since the angle has to, well, let me rephrase. This has to lie between negative 1 and 1, and since we satisfy this condition, the x satisfies the domain condition, and if you think about it, it does. Negative square root of 2 is less than 2 when you divide it by 3. Therefore, this will be greater than well, less than 1. Therefore, less than and greater than negative 1. So the angle, the answer is, this is a read-through problem. However, let's say if you did not realize that, you could do the triangles, label the triangles like this. So this is